So, Bismillah, wassalatu wassalamu ala Rasulillah. My name is Marwan Boudra, PhD candidate from Tbilisi University, and my PhD project is about historical documents classification under the supervision of Dr. Akram Noor. And in this presentation, we are going to present our work, which is titled Deep Learning-Based Approach for Historical Documents Classification. And in this presentation, I will mainly talk about these points. So first of all, we need to understand what are historical documents. And we have two types of historical documents. We have handwritten documents and written documents. Most of the challenge is laying on the handwritten document, which known as historical manuscripts. And the term historical means anything related to the past, while manuscripts means written by hand. So together give us the definition of historical documents, which are handwritten documents from the past. And these documents are written on a variety of materials, such as parchment, paper, papyrus, which is a plant-based material widely used in Egypt. And these manuscripts have various types depending on their content. For example, we have religious manuscripts, we have medical manuscripts, philosophical manuscripts, etc. So this highlights their crucial role in our society as a primary sources of information. Also, they give us cultural and social insights about our society, and also they preserve our heritage and protect it from change and extinction. So now what is script classification? What do we mean by script classification? Uh, the main problem is historical documents classification, and historical document classification is divided into subtasks and subproblems. For example, we have the problem of written historical documents, the authorship determination, the writer identification, etc. And one of the tasks we are treating is script classification. And script classification refers to the process of classifying historical documents in one of the type of scripts used. And it is important for historians and linguists because it helps them to give them insights about the date of the document, the author of the document, and also the location. So studying the literature, we can analyze the existing solutions, and we found that most solutions in this problem are image-based approaches because we are interested in visual characteristics of the document and not in the semantic or the content of the document. And most image-based approaches have three main stages. We have pre-processing, feature extraction, and classification. And in our study, we developed an end-to-end system that from pre-processing to classification. Now problems with existing methods. As we said, we have analyzed the existing solutions, and we can make an analysis that we summarize it in three main points that we have to design a solution that mainly tackle these problems. First of all, the lack of image samples. Also the bad documents quality and the complex features extraction algorithms. So we came up with a solution which is an image-based approach from containing three main stages from pre-processing to classification. As you see here, we started by the original image. Then we denoise it using non-local means algorithm. Then we binarize the denoised image using canny edge detection. After that, we detect key points using the binary image using array scoring detector. After that, we cluster the detected key points and then use these clustered key points to extract small patches from the original image. After that, we pre-trained models using transfer learning on these small patches. And finally, we perform majority vote on these patches to determine the final classification of the document. So we started by the denoising, and denoising is an important step for binarization. Why? Because binarizing the original image empirically don't give good results. So we need to use denoising, and for denoising we use the non-local means denoising, which demonstrated effectiveness in other studies. Next step is binarization, and binarization is an important step before key points detection because detecting K-points directly on the original or on the denoised image empirically also don't give good results. So we need to apply binarization before any K-points detection. And for binarization, we use the uncanny edge detection because it focuses on the edges which found in the writing styles. Next step is K-points detection, where the goal is to extract small patches from the original image. And for K-points detections, we used Harris corner detector, which give a good results. Next step is to cluster the detected K-points using K-means algorithm. The algorithm is iteratively update the centroids of the clusters until the conversions. And final step in the data preparation is to use the clustered K-points to extract small patches from the original image. And why we extract small patches from original image and not in the binary or denoised image, because we need to keep the originality and because of the physical characteristics of the document, such as the color of the documents and also the ink details, which will be lost if we, for example, train the model on the binary or on the denoised images. Next stage is classification, where we applied convolutional neural networks. We used transfer learning techniques, different pre-trained models such as ResNet, DenseNet, VGG, etc. And among the models, DenseNet give the best results, as we will see in the experiment section, because it's focused on the details of the writing styles. Final step in our classification system is majority vote, where we applied majority vote mechanisms on the small patches to determine the final classification of the document. Now we will see some of our experiments that we performed, and the goal is to determine the optimal parameters of our system, such as number of clusters K, such as patch sizes, and also the pre-trained model. And for the experiments, we used CLAM datasets, which utilized in ECDAR 2017 competition, which comprised of 3,540 images from 12 distinct scripts. The first experiment is about choosing the patch size of the document of the patches extracted. We tried different patch sizes, such as 150, 224, 550, 750, and the patch size of 550 give the best results compared to the other. Next experiment is about choosing the number of clusters K, and we tried different number of clusters, and we found that 16 clusters was enough to give optimum results. The final experiment here is about choosing the pre-trained models, and among the pre-trained models, we found that DenseNet 121 give the best results and give accuracy of 89.2. Finally, we compare our approach to existing solutions in the literature, which used in competitions such as ECDAR 2017, and we have outperformed other studies with accuracy of 89.2. So in conclusion, among our findings is that the combination of handcrafted features and deep learning features can improve the performance. Also, the use of patch-based solution is improving our results because the significant augmentation of the data. And finally, transfer learning with pre-trained models can enhance the results of our solution. So thank you for your attention.